Today we're going to look at section 2.3 where we're solving right triangles. So we'll begin by an example. So suppose we have a right triangle where C is 90 degrees, obviously. We want to find the remaining parts if we know that the measure of angle A is 41 degrees and the length of side C is 36 meters. So here's my triangle. Okay, and I'm going to label the information I know and then label the remaining sides and angles. So B and C, then the side opposite A would be A, the side opposite B would be little b. So what we need to find are the following measures. We don't know angle B, we don't know side A, and we don't know side B. Okay, so the problem again. So let's look at this angle first, B. We know they're complements, right? 41 and whatever B is have to add up to equal 90. So it turns out that B is 49 degrees. Okay, now we can look at this side lengths for A and B. Okay, let's look at side A. So we look at the information we have. Okay, so we have that angle A is 41 and we want to find its opposite, and we know the hypotenuse. So we have to use the correct ratio. So if I have an angle, what's the ratio between its opposite and hypotenuse? Well, of course, it's the sine. So now we can set up an equation that the sine of 41 degrees is equal to opposite over hypotenuse, or the sine of 41 is A over 36. I left my units out. Now we can evaluate sine 41 on your calculator, right? Just make sure your calculator's in degree mode. And we end up with 0.6561 rounded off is equal to A over 36. Now, to get rid of this in the bottom, we multiply both sides by 36. And it turns out that A is 23.6, but we're going to round it to two significant digits. So, we'll round it up to 24. So let's look at B. Okay, so we start with again with our original information. We have two sides. We could use the Pythagorean theorem, but let's hold off on that and use that as a check at the end. So I have this angle. I want to know its adjacent, and I was given the hypotenuse. So which ratio do I need to use if I have talking about adjacent over hypotenuse? Well, that's cosine, of course. So now let's set up this equation. The cosine of 41 degrees is B adjacent over hypotenuse, which is 36. So in the calculator, I find the cosine of 41.7547. That's equal to B over 36. Now again, I need to get to the B, so I'm going to get rid of the 36 by multiplying both sides by 36. And it turns out that we get 27.2. But again, I'm going to round to two significant digits. So B, we're going to write as 27. So we found all the parts, but it's always best to check your answers. So we make sure we have all the conditions met for a right triangle. Okay, so here are our measures we got. First of all, I need to make sure that all the angles sum to 180. Well, 41, 49, and 90 equals 180, so that checks. Next, I need to see if the side lengths fit the Pythagorean theorem. Okay, so if I take 24 squared plus 27 squared, it should be approximately equal to 36 squared. And it is, not exactly, but keep in mind that we use rounded values, so this needs to be approximate. Sometimes it'll turn out, to be much closer than other times, but it's close enough to say, yeah, we got that right. And then the last thing, we have to make sure that the right angles have the right opposite side associated with them. So we want to see if we arranged everything properly. So we want to know, is the smallest side opposite the smallest angle? Yep. The smallest angle is 41. The smallest side is 24. And is the largest side the hypotenuse? Well, yep. The side opposite 90 degrees is 36. So we check there too.